Alright, ladies and gentlemen, we are learning some more AB statistics. Hopefully we will finish 6.3. Little heads up and some minor changes with our schedule because of our 11th graders taking AP exam this week and missing all of this week's 2 blocks. We will postpone our test until Thursday of next week. That means, yes, that's right, if we finish today with 6.3, we will have Monday to work on homework and Tuesday and Wednesday to review. It's just a good, might as well. We'll do it. We'll do a little game on Tuesday, have some fun, share some laughs, do some z-scores, that kind of stuff. Maybe combine some means and standard deviations. Okay. All right, we left off here, and we actually answered this. I showed you how to do this in your calculators, and so we were all fine and giddy and just feeling fine and dandy. First off, you need a calculator. Second off, you need a pencil. Third off, you need to pay attention because you're going to be answering some questions in between the videos. So be using your brain. All right, here we go. First things first. How do we find the mean with a binomial distribution? How can we find a mean given a binomial distribution? Well, it works the exact same way. All right. So I can, multiply down and add across, right? So I can do the multiply down, add across, and you guys love doing that, right? Okay, cool. You could do that. However, something really cool about binomial distribution is that you guys have actually been doing binomial distribution means your entire life. Because, like, for instance, all right? So let's say that ESP thing. Remember? The ESP, there were 10 questions, right? Now, what was the probability of getting one of those 10 questions right? Well, you had a 1 in 5 shot, right? Which, last I checked, that was a 20% chance. So, normally, you guys would say, oh, 20% chance, I have 10 questions, that means I should be able to get, like, 2 correct, right? Yeah, that's the average, okay? There's a slick as spit formula for finding mean from these binomial ones. All right, and let's take a look at that formula for binomial. Here is the formula. By the way, you like this that I can write in orange now because I'm using my tablet. It's a little delayed, but I can write in orange. I can change the color up. Ooh, let's do something a little scary here. Whoa, I'm gonna put a little purple on there because I'm feeling fine. All right. So I got the orange, I got the purple. All I have to do is take how many things I have times the probability. So, for instance, let's do one more. Since I got this line up here, flipping a coin is 1/2, right? Right? A heads would be a half. What would be the average? What would you expect would be the average if you flip the coin 100 times? So I'm going to go 100, which is my n, times 1/2, and so my average, what I would expect, how many heads should I get? 50 heads, right? All right, like I said, we've been doing this probably before you can even remember. That's the cool part about it. All right, so there is one other formula, okay, and that's how to find standard deviations given a binomial distribution. So the formula for a binomial distribution is this guy, and you will memorize him. You will, or you will fail, I guess, or take a really long time doing homework. It's not that hard of a formula to memorize. We have to use this pretty much from here until the end of the unit, or to the end of the year. So you're going to want to make sure you use this. But here's the formula. Basically, you're going to do the square root, and let's say we do the 100 with 50 flips. So I'm going to go 100. Sorry, it's a little delayed here. 100. And then my probability is 50%, right? And then 1 minus p. So we're talking this stuff right in here. We're talking about this. I know it looks a little confusing, but we're talking that right there. And that is all it is it's just the inverse. Basically, what's the opposite of 50%? What's 50%? So it's the square root of how many you have times the probability times its inverse. And boom, we should have an answer. Okay? Try it. Okay? The answer is 5. Right? Now just remember, these formulas only work for binomial distributions. So it's only when you have, remember, binomial is your bins, and I'm just going to review this because of the next slide. All right? B stands for binomial, meaning 2, success, fail. I stands for independency. N stands for there has to be a set number, so like 100 flips or 10 questions. And then S stands for the successes have to be the same probability. So you can't have like 50% success on one flip and 45% flip on the other. So that is your bins. Okay. Oh, for crying out loud. Do I really want to do this? I don't really want to do this. You guys can figure this out, right? I mean, you got 21. So the mean is, let's see, I got 21 times the probability. So what do you think a third of 21 is, right? What's a third of 21? 7. Okay? What's the standard deviation? Okay? Like I said, you're going to have this memorized. It's going to be the square root of 21 times a third. What's the opposite of a third? Remember, it's that 1 minus p. Well, the opposite of a third is 2/3. Okay? And the answer is 2.16. That's what I got. And I'm sticking to it. By the way, I didn't see any of you guys in karaoke I-block yesterday. Very disappointed. Very disappointed. By the way, I sang This Is the Moment a couple days ago. You missed it. It was a very stirring moment. There was not a dry eye in the small odd. All right. Last thing we got to learn here, and we got about 8 minutes to do it. It'll be fast. Is geometric. Okay, so we had binomial, which was our bins. Geometric is our bits. So it's our bins and our bits we got to remember. So everything is the same about a geometric setting except for one thing. All right, everything is the same except for one thing. All right, and that thing is, sorry, this is driving me nuts here. Ugh, I'm never going to get it in my, there we go. There we go. The one thing that is not the same, let's go back to orange, is this guy, trials. Notice, binary, got to have a success and a failure, independent, but trials takes the place of n. And here's the difference. Binomial has to have a set number. Geometric means you go until you reach success. So it's kind of like those, those times when you're outside playing ball, or you're playing frisbee, or playing football, or shooting baskets. And you're like, okay, we'll go home after we reach, all of us make the next basket. Right? And so we keep shooting until we get our success, right? Or maybe we'll throw frisbee, and we'll do it around in the ring until everybody catches it and throws it without anybody dropping it, and then we'll go home, right? Okay? You guys know you are there. One of you, all of you have done that, I know. All right? It's not just a Shivi tradition. So that is actually geometric. So next time you do that, okay, that's geometric. All right? So, there's not a set number. We just go until we succeed. So here's the thing. It's going to be really easy. All right? Okay? I got a birthday problem. Now, in the story problem, and I think I stated a little better in your notes. But let's just say I'm going to assign your homework by how many times you guys can't guess one of my friends' birthday. All right? So, for instance, all right, let's just say, all right, guess the day my friend Jonathan was born. Guess the day my friend Jonathan was born. Now, you would probably say that the odds of getting that is a 1 in 7 chance, right? And sorry, my thing is a little delayed here now. Okay, if you're 1 in 7, let me go to this. 1 in 7, right? Okay, so the odds of you getting it right on the first time is 1 in 7. Well, the odds of you getting it wrong is actually 6 out of 7, right? Okay, that's the odds of getting it wrong. I don't know why this thing. Did I accidentally hit the power button? I did hit the power button. There we go. Uh-oh, it's dead. My thing's dead. All right, we'll go live. So, anyways, so what's the odds of guessing my friend Jonathan's birthday? All right. Now, one of you guys would guess, and if you got it wrong, because live I would have you guess, then we would move on and you'd have to do one homework assignment. And then I would say, okay, now somebody else try and guess my friend Heidi's birthday. And you'd guess, and if you got it wrong, we would have to do 2 homework assignments. Does that make sense? So this would be a scenario of a geometric because we're just waiting until somebody gets it right. And then we stop and we don't have to do any more homework assignments. All right. So what's the probability of getting it on the first try? Well, getting it on the first try is going to be 1/7, right? Would you agree? That's the probability. What about probability of getting it on the second try? That means, these formulas are really easy. That means we have to fail once, so 6 out of 7, times, that's 1 failure, and then succeed, right? That makes sense? So 1 failure, and then I would succeed. That's going to be the probability. Is that making sense? What's the probability of getting 3 correct? Well, or on getting it correct on the 3rd time? Well, that means I would have to have the first 2 fail. So like if I had Maddie and Audrey guess first. And then, so I'd have 2 failures. And then on the 3rd time, I say, all right, Chloe, what's this? And then, of course, Chloe always gets it right. So she would get it right on the 3rd time. All right. So that would be the probability of getting it on the 3rd try. So we've done these kind of things before, but you got to realize we have 2 failures and 1 success with 3 tries. All right. That's it. It is really that simple. So let's just figure this out quick. All right. I'm going to pause it, and then I'll display the probabilities. All right. Now with only 2 minutes and 20 seconds left, here are the probabilities. Probability of guessing it right on the first time is 14%. Probability of guessing it right on the second time is 12%. Probability of guessing it right on the 3rd time is only 10%. In theory, guys, then, right, when's the best probability, or when's most likely to happen? On the first try. That is when it is most likely to happen, because anytime we start multiplying by more decimals, this number gets to be smaller. So most likely it will always happen on the first time for geometric. All right. Last question. Shaquille O'Neal, one of the worst basketball free throw shooters in the world, and he averaged 52.7. I don't know if I'm going to have enough time, but that's a .527. Forgive my writing. I am back to mouse style. All right. That means his failure rate is a .473. I think that's the opposite. Okay, so what is the probability that Shaq misses the first 5 free throws before he makes a 6th? So that means he has to fail. All right, how many times does he have to fail? And instead of writing this out 5 times, I'm just going to go like this, right? He fails 5 times, and then he succeeds. All right. What is that probability? The probability he makes it to the 6th shot before making a free throw is 0.0125. All right. Now, that's not very good odds, but that means it has to happen on the 6th time. What is the probability Shaq makes a free throw in 4 or less shots? That means I not only have to do the 4, but I also have to do the 3, the 2, the 1, and the 0. All right? Now, there is a button in your calculator. All right? Remember, you can go second vars. It's distribution, And then look for a geometric CDF. That'll find the cumulative. Bye, guys.